Good afternoon. Today we are plotting points in a coordinate plane. First we are going to label the coordinate plane and then we'll get to plotting some points. So first, some different parts of the coordinate plane. We know this line that goes left to right, this is our x-axis. And our line that goes up and down, this is our y-axis. If you don't remember which is which, put the x and the y next to each other. The letter y is longer, it goes up and down just like the y-axis. The x is shorter, it goes left to right. So kind of helps you out figuring out which one is which. Then a couple other parts. This point in the middle here, we call this the origin. That is the center. And then we have four different quadrants. Our x and y axis divide these into four quadrants. This here would be quadrant 1, or sometimes just Q1. And then we go counterclockwise, like opposite of a clock, this way around to our other coordinates, or other quadrants. This would be quadrant 2. This would be quadrant, just going to shorten it, quadrant 3. And this would be quadrant 4. Erase my arrow because I'm going to have to plot some points. So those are my four quadrants. It says, what quadrant is Q in? Well, Q, the letter Q is in quadrant 2, but the point itself right there is really on this line. It's on the x-axis. So that's kind of a trick question. It's not in a quadrant, it's on the x-axis. But P over here, P is in quadrant 4, or Q4. Then down here it says, plot the points in a coordinate plane and describe the location of the point. So when we plot a point, remember it goes in alphabetical order, x then y. So first we're going left and right, and then y we're going up and down. So this first point, x, we're not going left and right. We're staying right in the middle at 0. And y is -5, so down 1, 2, 3, 4, 5. They said to label that with a Q. And that point right there, 0, -5, is really on the y-axis. They said describe the location, that's what they mean. Where is it? Which quadrant? Then point R, x and then y. On my x-axis, left and right, I'm going 2, positive 2 to the right. And then 4 is up, 1, 2, 3, 4. So that's point R, and that you can see is in quadrant 1. I'm just going to write Q1. Then this point, -7, -4. So x is -7 to the right on the edge, -7. And then -4 is down 4 right there. That would be point S, and it is in quadrant 3. And then last, point T, x is 3 and y is 0, so 3 to the right and 0 is right there. That is on the x-axis. So there's some plotting points. We had a point and then we plotted it. Now we're going to go the other way. Here are some points. We need to label our coordinate x, y, or our ordered pair. Always x first, going left to right, and then y going up and down. So to get to point B right here, x first, I'm not going left and right, I'm staying at 0. And then y is, I'm just going down 1, or -1. And then point D, D is over here. X-axis first, we went -1, 2, 3, 4. And then up 1, 2, 3. A positive 3. You don't really need to put the plus, you can just write 3. -4, 3. Our next point, point F, right here on our x-axis first we went 1, 2, 3 to the right. And then y, we didn't go up and down, so 3, 0. Then point H, where's H? Oh, down here. We went to the left, -1, -2, -3. And then down 2, so -2. Point K, right here. X first, we went 1 to the left, so -1. These are negatives also. And then up 1, 2, so positive 2. And our last point that we're going to look at is point C. To get there, x first, 1, 2, 3, 4. and then y up 1, 2, 3, 4. Whoa, that was not very even. But you should be able to get the idea. 1, 2, 3, 4. Positive 4. That is the whole lesson on 4.1 plotting points. You won't have homework specifically on that, but you need to use that information to solve and apply lesson 4.2, which is graphing linear equations. So in order to graph this, we always have to solve an equation for y. We need to get y all by itself. We call this function form, remember? So I'm going to draw my line down. I need to get y by itself, so this I need to move to the other side. I'm moving the whole thing, and the whole thing is negative, so I'm going to do the opposite of what I see and add 2x. So I have y equals, now I can't combine just a number with an x, so I'm going to write them separately. 2x minus 3. If you write your x's first, it'll make your life easier later, okay? Now it says, make a table by choosing a few values for x and finding the value for y. Now if they don't tell you what to plug in for x, I like to plug in 0 because it's in the middle and it's easier to multiply and add 0. And a couple positives, 1, 2, and a couple negatives, negative 1 and negative 2. If you picked numbers just like 0, 1, 2, 3, 4, 5, your graph might not fit on here, so we want to pick some that are going to be right in the middle, as close to the middle as we can. So first, I'm going to plug in a negative 2. So it says, I'm just going to rewrite this equation over here. It says we're plugging in a negative 2 for x. So we have 2 times x, which is negative 2, and then subtract 3. I just didn't write the y equals because we're assuming that's what we're going to get out down here. So 2 times negative 2 is really negative 4. So negative 4 minus 3, they're all negatives. That gives us a negative 7. Then we're going to plug in a negative 1. 2 times negative 1 and subtract 3. Well, 2 times negative 1 is negative 2. And subtract 3, that gives us a negative 5. Then plugging in a 0, anything times 0 is just 0. So 0 minus 3 is negative 3. Now if you see a pattern, 7, 5, 3, I can assume the pattern is going to continue. So I know we're going up by 2s, going closer and closer to 0. Next would be a negative 1. And then 2 more would give me 0 and then a positive 1. If you're not sure, go ahead and plug in all of the numbers. Now it says plot the points. This is my x-axis, and this is my y-axis. So our points are always x then y, so x is negative 2, y is negative 7. So let's plot that point. X is negative 2, y is down 1, 2, 3, 4, 5, 6, 7. Then our next point is negative 1, negative 5. So negative 1 to the left, and down 5. Then our next point is 0, negative 3. Always x and then y. 0, not left and right, just down 3. Then the point 1, negative 1. X is 1 to the right, negative 1 is down 1. And these should be forming a straight line. If they're not, we made a mistake. And our last point, x is 2, y is up 1. So we plotted the points. If you don't need to write it as an ordered pair, that's fine. If you can see it right from our xy table, that's fine. Last, connect the points by drawing a line through them, and use arrows to indicate that the graph goes on without end. Ooh, that was not so good, but you get the idea. Don't just put a line from here to here and call it good. I want to see your arrows on both ends. Make that line continue. Because we could have plugged in other numbers. We could have plugged in a 3 and a 4 and made this go on and on and on. Okay? Let's try another one. I don't have the steps listed here for you, but we need to remember them. So in order to graph, first we need to solve for y. So let's get our x's over to the other side first. The opposite of a positive is going to be a negative, or subtract 4x. So we have 3y, and write your x's first, negative 4x plus 12. It'll just make your life easier later. And then last, the opposite of multiplying is divide by 3. Divide every single piece by 3. 3 over 3 is just 1. 4 over 3, I don't know what that is. I'm just going to leave it as negative 4 over 3. Plus 12 divided by 3, which is 4. Our second step, after we solved for y, was step 2, make a table. So I'm going to make an xy table. And I am going to plug in numbers, but this time instead of choosing 0, a couple negatives, and a couple positives, I'm not going to get nice numbers unless I plug in multiples of 3, because our denominator is a 3. If our denominator was a 2, I would plug in multiples of 2. If our denominator was a 5, I'd plug in multiples of 5. But since it's a 3, I'm going to plug in multiples of 3, like 3, 6, 9, and so on. But I do still want a couple negatives and a couple positives, as close as I can to 0. Alright, so first I'm going to plug in a negative 6. So, oops, I forgot my x in my equation. We have negative 4 over 3 times x, and x is first a negative 6, and then plus 4. I'm going to make this a fraction because we're really just multiplying these. Negative 4 times negative 6 makes a positive 24. 3 times 1 is 3. So 24 divided by 3 is really just 8. So we have 8 plus 4. So adding those up, we get 12. Then I'm going to plug in the next number, negative 3. Negative 4/3 times x, which is 3. And then we're going to add 4. Again, 3 is 3 over 1. Negative, oops, this is a negative 3. Negative 4 times negative 3 is a positive 12. On the bottom we have 3. 12 divided by 3 is really just 4. So we have 4 plus 4, which is 8. Then we're going to plug in a 0. Negative 4/3 times 0 and add 4. Well, anything times 0 is 0, so I just have 4. Now I see a pattern. I'm going down by 4 each time. So if I go down by 4 again, I'd be at 0. Down by 4 again, I'd be at negative 4. So let's plot these points. Remember, our points are always our x and then y. Here's my x and my y axis. So our first one, 12, we can't really graph that because this only goes to 10. 10 is the top. So we can't graph that one. That's okay. We're going to start with the next one. Negative 3 on my x-axis. Negative 3 to the left. And then up 8. 1, 2, 3, 4, 5, 6, 7, 8 right there. Then 0 left and right on my x-axis and positive 4 right there. Then 3 on my x-axis, 1, 2, 3, and y is 0. We're not going up and down. Again, if you want to list them out as points, you can. And then 6 to the right, negative 4, negative 1, 2, 3, 4. So draw a line through it here and put arrows on the ends to show that it is going to go on and on and on. And there's our graph. The next one, very similar. We need to solve for y. The opposite of a positive 4x would be subtracting 4x. Those eliminate. We have y equals, write your x's first, negative 4x plus 1. And then we need to make a table because we don't know what to graph yet. This one, there's no fraction, so we can plug in 0, a couple positives, and a couple negatives. So first, plugging in negative 2 here for x. It says negative 4 times x, which is a negative 2, and then we're going to add 1. Well, negative 4 times negative 2 is 8. 8 plus 1 is 9. Then negative 4 times a negative 1, plugging in that negative 1 right there. Two negatives multiply and make a positive 4. 4 plus 1 is 5. Then plugging in a 0. Anything times 0 is 0. 0 plus 1 is 1. You might notice we're going down each time by 4. So if I subtract 4 again, we'd be at negative 3. Subtract 4 again would give us negative 7. So let's plot these points. First point is -2, 9. So x and y. -2 is to the left. 9 is up 9. Goes to 10, so 1 less. Then our next point is -1, 5. -1 to the left, up 1, 2, 3, 4, 5. Then 0, 1. 0 is not left or right, it's just up 1. Then we have the point 1, -3. So 1 to the right, and -3 would be down 3. And then 2, -7. 2 to the right, and down 7. Use the edge of your book, a ruler, or something to draw a nice straight line. And then put arrows on the ends to show that it could go on in both directions. It's not a line segment, it is a line. Alright. Next we have a couple problems that look a little confusing. All the ones we've done so far are functions because we have y equals. It's called function form, remember? Now we want to know, is this a function? It says y equals 2.5. Well, if I go about it the same way, I'm going to make a table and plug in my numbers 0, 1, and 2, and then -1 and -2. There's nowhere to plug in an x anywhere. There's no x's. So every time y is just going to be 2.5. So when I go to graph this, my points here, x is -2, so 2 to the left, and up 2.5. 1, 2.5 would be right in the middle there. Then -1 to the left, up 2.5. Then 0 in the middle, up 2.5. As you can see, this is forming a horizontal line. This line would go on and on and on in both directions. Oopsies. In both directions right there. This is a function because it has y equals. So yes, this is a function. Later we'll talk about slope. This has a good, nice slope of 0, which is fine. But over here, this one what says x, we already know right away this can't be function form because it doesn't have y equals, it has x equals. So no, it's not going to be a function. However, we can still graph it. So if I make my xy table, the problem is I can't choose my x's because x every time is going to be -4. That's what they're telling me. So if I know the x's are always going to be -4, I have to then flip-flop and choose the y's. So my y's would be 0, 1, 2, -1, and -2. And then we just have to plot them. X is -4, y is -2. X is -4, y is -1. X is -4, y is 0. And we would form a vertical line. If you have a vertical line formed, this is not a function. It's not in function form. It doesn't say y equals something. It says x equals. So we say vertical lines. We don't like those. They're not a function. Not a function. And we just made tables to graph these, which is fine. But if you'd like a shortcut instead, one thing we are going to do, or to say, is in order to graph this, we're going to read this like a sentence. We are going to cross, oops, let me move this out of here. We are going to cross the y-axis at 2.5. Here's our y-axis. We crossed it, went through it at the number 2.5. So it had to go left to right. It couldn't go up and down because then it's going through the whole everything on the y-axis. That doesn't make sense. So we are crossing at that number. So this one, we would have crossed the x-axis at -4. So here's our x-axis. Here's -4. To cross it, we'd have to go through it up and down. So that would be a vertical line. So let's look down here. If we graph this one without using a table, we are going to cross the y-axis at -4. So here's the y-axis. Here's -4 on the y-axis. If we're going to cross through this line, we would have to be going left to right or horizontal. So this is what our line would end up looking like. Whoa, let's try that again. And put arrows on the end to show it could go either direction. We just graphed that without using a table. Same thing here. This one we would cross the x-axis at 2. So here's x-axis, here's 2. In order to cross it, we'd have to go through it. Our line would have to be going up and down, and this one would be a vertical line. And arrows on the end. And those are our ones that some people find a little bit tricky, but if you read it like a sentence, it's probably one of the easiest ones to do. You don't even have to make a table. Alright, I think this is our last, oh, we got 2 more. Graph the function represented by a table. It says hourly pay. The table shows the number of hours worked and the corresponding pay in dollars. So hours worked, 1 hour, you get paid $7.50, 2 hours, and so on. Part A, graph the data. So hours worked is on the bottom here. This is really our X. This is really our Y. So after 1 hour, we've made $7.50, which is a little less than 10. Then after 2 hours, we would make $15, right between 10 and 20. Then at 3 hours worked, $22.50. Notice we're forming a straight line here. At 5 hours, we would have $37.50, so a little less than 40. And then jump over to 8. At 8 hours worked, we'd be at 60. So we graphed it. Does the graph represent a function? Why or why not? So let's look. Do these make a nice straight line? Because we did a little approximating, I would say yes, they do. So function form, remember, function form means they are going to be a straight line. Oops, S-T-R-A-I-G-H-T. Means they're going to be a straight line. So does this represent a function? Yes. The points form a straight line. And then last it says describe, so that means you're going to use some words here. Describe the change in hours worked and pay. So as our number of hours worked is going up, what's happening to our pay? Our pay is also going up. So you could use words such as going up, increases, gets larger, however you want to describe it. So I'm going to say, as we work more hours, our pay increases. Like I said, there are a variety of ways you could have said that. Last one. It says running. The distance d in miles that a runner travels is given by the function d equals 6t, where t is the time in hours spent running. The runner plans to go for a 1.5 hour run, 1.5 hour run. Graph the function and identify its domain and range. So, here, our time in hours, we could start off at 0. We can't go negative because you can't run negative time. That doesn't make sense. So time in hours, 0, and we have to go all the way up to 1.5. So this one is only between these two numbers. So to get from 0 to 1.5, we could go by 0.5s. Add another 0.5, we're at 1, and then 1.5. That way they're equal distant apart. So our equation says d equals 6 times t. And t is our time. So first, if we plug in a 0, 6 times 0 would just be 0. Well, that makes sense. If I haven't gone anywhere, or if I haven't spent any time running, that means I haven't gone anywhere. Then 6 times 0.5, or 1/2, half of 6 would be 3, or just use your calculator. 6 times 1 is just 6. If you see our pattern, we're going up by 3 each time, so our next number would be 9. So if we graph those, 0, 0, then 0.5 to the right. Instead of literally going 0.5s, I'm going to make these go, each of these by 1s. 1, 2, 3, 4, on just my x-axis. So at 0.5, which would really be in the middle here, we're up 3. 1, 2, 3. Then at 1, we're up 6. And then at 1.5, we're up 9. So this one we can't put an arrow on because they say they're only going for up to 1.5 hours. So this is our answer right here. There's no arrows. That's called a line segment. It says identify the unspecified domain and range from the table or the graph. Remember, our domain is what we plugged in. We plugged in the numbers between 0 and 1.5. Your answer key might say something a little bit different, and that's okay. It might say the numbers between 0 and 1.5, which is fine. And our range is what we got out, the numbers between 0 and 9 miles. 0, 3, 6, and 9. We could have stopped at different points along the way if we were running. So if you wanted to say between 0 and 9, that's fine as well. Your homework is out of the book. If it says anything about a restricted domain, just ignore that. Just graph it like you would normally graph an equation.